Hello everybody, today we're going to look at some algebraically tricky limits, and the first one I'm going to walk you through is the limit as x approaches -1 of the quantity x cubed plus 1 divided by x plus 1. Now if we think about that, if I put in the -1 directly, I would find that I have -1 cubed is -1 plus 1, that's 0 divided by 0, and that's called indeterminate form. Anytime you have 0 over 0, that's indeterminate form. There are other indeterminate forms. One that we'll look at as well is infinity over infinity, but I'm not going to do that one today. The thing about this problem is when you have indeterminate form, you have to make sure that don't go directly and say this limit does not exist. Just because it had a 0 on the bottom doesn't mean it doesn't exist, but instead, if you get indeterminate form, you ought to think more about potential algebra that you could do to actually find the limit. Now, if you take and notice I have the function here in Desmos and I graphed it. Well, this graph looks a lot like a parabola, and in fact, everywhere except for at -1, it is a parabola. As you know, we have a domain restriction. It's going to be all real numbers. X is an element of all reals, such that x cannot equal -1. All right, but everything else works. And in order to figure out what is that limit, what y value are we going to, we need to take care and try to work on some algebra here. And the question becomes is, at one point, you probably knew how to factor out the sum of cubes, and maybe you remember how to do that, and maybe you don't. There's both the sum of cubes, which is what we have, and the difference of cubes, which you can take a look and try to find that out on your own. But if you remember how to factor that, it becomes the binomial of x plus 1 times x squared minus x plus 1. Now, if you don't remember how to factor that, one of the clues that you could work on is by taking a look at what term is on the denominator, okay? So I have an x plus 1 on the denominator. I'm going to try to eliminate that x plus 1, so maybe it is a factor on the numerator. Anyway, go ahead and review that at some point if you don't remember that. But with that factor of the x plus 1 available on both the numerator and denominator, then I can cancel it out. And I get the limit as x approaches -1 of x squared minus x plus 1. And since when I put in the -1 now, I just have 1 minus a -1 plus 1. So that's going to be 1 plus 1 plus 1. And that value is 3. So our limit of the function as x approaching -1, that is 3. The function value, it does not exist. So our limit, if I were to be able to take a look up here on the graph again, I would fill in this y value, and this y values would be a limit of 3. So doing a little sketch down here, I have the functions coming down. Looks like a parabola. It is a parabola with the exception, as I said, at -1. At -1, there's a hole, and that hole's y value, I don't know how well this green is working. I'm not sure if you can see it or not. Hopefully you can. The hole's value -1, 3. Again, there's a difference between the limit and the function value. So the function value doesn't exist, but the limit does exist, and that limit is 3. Now's a good time to pause and contemplate this one, and I'll move on to a second problem momentarily. Hi, everybody. The second problem that I want to look at is the limit as x approaches 25 of the square root of x minus 5 divided by x minus 25. And if we try our standard way to go of putting in 25 at first, I'm going to have the square root of 25 minus 5 over 25 minus 25. And once again, I get 0 over 0, which is indeterminate form. Okay? When I see indeterminate form, I have to think about, is there anything I could do algebraically to actually find this limit? And I've included the graph of this function twice, only just so that you can see at 0, the graph isn't at 1, but it's just slightly above 0. And it looks like we're trying to deal with x approaching 25. It certainly looks like the left hand and the right hand limits are approaching some value. I don't know what the y value is yet, and that's what I'm trying to find out. But it certainly looks like there should be a value. And so I have that indeterminate form. I'm going to try to figure out what I should do. And when you have a square root of x minus 5, you may remember from your pre-calculus or your Algebra 2 days about multiplying by the conjugate, which that is, and of course, a form of 1. Now, the conjugate of the square root of x minus 5 is the square root of x plus 5. Now what I'm going to do here is I'm going to do that multiplication out on the top, and you may or might not remember these two are the difference of squares. Okay, they're factored out. It comes out to the difference of squares, and it comes out to the difference of squares of x minus 25. And I'm not actually going to multiply the two binomials on the bottom together. I'm just going to show that they would be multiplied together. But I'm not going to do that because I can now see that the factors of x minus 25 will cancel one another. Now, I did something that I should not have done, and it is something that I'm going to make sure that you do, and with my mistake, hopefully that'll help you remember. Every time that you write the function, your work expanding from one spot to the other, we must include the limit as x approaches 25. Now, because those are two different problems if I don't include the limit as x approaches 25. Without it, I'm just doing some division. So for the next phase of this problem, I'd have those two terms would cancel out, so I would have the limit as x approaches 25 of 1 divided by the square root of x plus 5. Now if I take and evaluate the limit there at 25, I have 1 divided by the square root of 25 plus 5, and that leads to 1 over 10, 1/10. So I have just found that at the coordinates 25 and 1/10, the function that we were working has a hole at that point. So this would be up here, this would be the point 25 1/10, and the graph would have a hole there. So this is a good time to pause, and I'll get back to the third and final problem. Okay, the last problem I want to look for in this section is the limit as x approaches 6 of the quantity 1 over x minus 1/6, all divided by x minus 6. And if you go ahead and you put in the 6 and evaluate that expression, you would get 0 over 0, which at this point you should know that's indeterminate form. And if we have indeterminate form, you should think, is there anything I could do algebraically in order to solve that? Now, again, I said it in the previous one, if you get 0 over 0 in indeterminate form, do not assume that the limit doesn't exist. As you can see on the graph up here, I'm looking at the value 6, okay? It certainly looks like the graph is approaching, as x approaches 6, that the graph is approaching some y value. And I don't know what that y value is yet, but it looks like it is getting to some number. Okay, so the question becomes, what am I going to do when I have these kind of problems? Well, on the top, on the numerator, I have two fractions that want to be subtracted. So I'm going to take and I'm going to make a common denominator with those, and the common denominator is going to be 6x. So I need to multiply the first one by 6 on both numerator and denominator, and I need to multiply the second term there by x. And my denominator, overall denominator, is going to stay the same. So I'm just working with the numerator. So that leads to the limit as x approaches 6 of 6 minus x divided by 6x divided by x minus 6. Now sometimes students often forget how to divide that. 6 minus x divided by 6x divided by x minus 6. And it can be helpful to think about that as 6 minus x over 6x divided by x minus 6. It means the same thing. I just rewritten it. And when I do that, perhaps you'll remember that you multiply by the reciprocal. Okay? And again, some little algebra there. These two terms do cancel one another out, with one of them being a negative 1. So if you think about multiplying the negative 1 into here, you'd end up with a x minus 6. So they do divide with a remainder of negative 1. So I have negative 1 6 over x. Okay, so I'm going to take it back up to the original part here. So this leads to limit as x approaches 6 of negative 1 over 6x, and I have a value of negative 136. And okay, that's it for today.